Welcome to Pratham Science Academy classes, and we are about to start the set 4 of 2023. ये है set 4 of 2023. So we are going to solve only the physics section. So I have collected all the questions of the physics. इसमें से physics 8 questions हैं. The first question is the question number 13. It says that two LED bulbs of 12 watt and 6 watt are connected in series. So there are two LED bulbs. Let these be the bulbs, and they are connected in series. Series का मतलब है they are connected end to end. So this is the 12 watt bulb and this is the 6 watt, so they are connected end to end. Okay. Now, if the current through 12 watt bulb is, so this is the current through 12 watt bulb which is 0.06 ampere. So what will be the current to 6 watt bulb? अब हमें पता है जो सीरीज में रजिस्टर्स है या डिवाइस है उनके थ्रू करंट जो है वो सेम ही रहता है. So current is same in each of the devices connected in series. So इसमें भी जो current है वो 0.06 एम्पियर ही रहेगा. तो हमारी ऑप्शन है ऑप्शन बी. So option B is the correct answer for this one. Okay, for next question, that is question number 14, we have to select the correct pattern of magnetic field lines of the field produced by a current carrying circular loop. Okay, these are all the circular loops. And if you see the direction of the direction of current जो है वो सभी loops में same है. The direction of current is same in each of the loops. So this is the direction of the current, positive to negative. We have to find the exact pattern of the magnetic field lines. And I will show you how to find the exact pattern of magnetic field lines. And this is a current particular loop. In all four cases, this is a current carrying circular loop. A current carrying circular loop है और okay, let me draw it here. ये है, this is the current carrying circular loop. This is the connected to the positive terminal of the battery. This is the negative, and the current is going in this direction. This is the direction of. So how do we find pattern of the magnetic fields? Now in this case, इसका जो हर एक section है, like each and every section of this current carrying circular loop. So this every section of this wire, it contributes to the magnetic field lines in the same direction and within the loop. So every section will contribute to the pattern of the magnetic field lines, और pattern of magnetic field lines जो है वो रहेगी concentric circle की. तो और इसमें हम rule use करेंगे right hand. Right hand rule says that if we grasp the conductor in our right hand, so if we grasp the conductor in our right hand such that thumb points in the direction of the current, then the direction in which the fingers curl will give us the direction of the magnetic field line. So if we grasp conductor in our right hand, such that if thumb, अगर आपका thumb points in the direction of current, then the direction in which the fingers curl, the direction of current, I is current, then the direction in which the fingers curl gives the direction of the magnetic field line. So I'm going to apply it now. Gives the direction of magnetic field lines, and those will be the pattern in the form of the concentric circles. Okay, I'm going to apply this here. So if I grasp this conductor in my right hand, then the fingers are coming from the plane of the paper. It's not going into the plane of the paper, it's coming from the plane of the paper. So let me first draw the concentric circles and then I will give the direction. So at this point, these will be the concentric circles. So, and so let this be the concentric circle, and by the time we reach the center of the circle, It's almost a straight line. So at this point, if we use, because this is the direction of the current, so if we graph the conductor here and in our right hand, so direction of the current is in this direction. So the fingers will be coming from the plane of the paper. So that means this is the direction of the magnetic field lines. The fingers will be coming from the plane of the paper. So here the direction is this one. Okay, let's consider this point. And let me draw concentric circles here as well. यहाँ पे अगर मैं concentric circles बनाऊं तो concentric circles ऐसे ऐसे रहेंगे उनकी सिर्फ मैं ये center वाली magnetic field lines बना रहा हूँ by the time we reach the center. Okay, here the direction of the current is in this direction. And if I apply the right hand thumb rule, so here the fingers are going into the plane of the paper. So fingers are going into the plane of the paper means this is the direction. The fingers are going into the plane of the paper and will be coming out of the plane of the paper. Let me give the same direction to these lines. So this will be the arrows going into the plane of the paper. So going into the plane of the paper, and this matches with the option C. So option C is the correct answer, and the right rule we have used here is the right hand thumb rule. It's not right hand rule, sorry, it's right hand thumb rule. If you apply this at these 2 points, just draw the concentric circles and apply in the right hand thumb rule at these 2 points, and that will give you the direction. So this is the direction which matches with the option C. So option C is the correct answer for this one. Okay, for next question, it's given that this is question number 15. The resistance of a resistor is reduced to half its initial value. Let R dash with the new resistance and R with the initial resistance. So this is the new resistance. If other parameters of the electrical circuit remains unaltered, the amount of heat produced from the resistor will become. And we know that heat produced in a circuit is given by the Joule's law of heating, that is H is equal to I square RT. But we are not going to use this as it is because uh, when resistance is reduced, the current is also changing. It's given that the other parameters remain unaltered. So that means the other parameters is V is constant. We are going to take only those parameters which are unaltered. So this is going to change. So we know that V is equal to IR and we are going to replace I. So I is equal to V by R. So this I square becomes V square by R square into R into V. So this is the heat produced in terms of this V is constant and V square R by T. Let this be the heat produced. Now let H dash be the heat produced when the resistance is the new resistance. So that is equal to V square. R dash is R by 2 into T. So this becomes 2 times V square R by T. Now this V square R by T is the initial heat produced. So this becomes 2 times. So new heat produced becomes 2 times the original heat produced. So that means our option is option B. So B is the correct answer for this one. For next question, it's given that an alpha particle enters a uniform magnetic field as shown. The direction of force experienced by the alpha particle is. Now the direction of the alpha particle is it's a positively charged particle. So this is the direction of the current, and this is the direction of the magnetic field, which I'm going to denote by B. And in this case, we are going to find the direction of the force experienced by the alpha particle because it's moving in a magnetic field. And for that, we know we are going to apply Fleming's left hand rule. And Fleming's left hand rule states that if we stretch the forefinger and the middle finger and the thumb mutually perpendicular to each other, then if your forefinger points in the direction of the magnetic field and central finger gives the direction of the current, then the thumb gives the direction of the force. So let this be the direction of the magnetic field, this be the direction of the current. Direction of the magnetic field is given by the forefinger. or the index finger, and the direction of the current is given by the middle finger. So you have to point these two fingers in the direction of the forefinger and the middle finger of your left hand. So this is the direction of the force in which your thumb points. Okay, now here, if we consider this to be a plane of paper, let this be a plane of paper. And if this be a plane of the paper, then I'm going to use my left hand. This is the direction of the magnetic field, the forefinger, and the direction of the current is downwards given by the middle finger, and now the thumb is pointing towards me. So if this is the plane of the paper, then this thumb is pointing out of the plane of the paper. So this is out of the page. So D is the correct option in this case. Okay, for question number 20, it's given a current carrying straight conductor experiences a force when placed perpendicular to the direction of the magnetic field, which is true according to the Fleming's left hand rule. And the net charge on a current carrying conductor is always zero, which is also true, but this is not the correct explanation of A. So that means our option should be B. Both A and R assertion and reason are true, but R is not the correct explanation of A. So B is the correct answer for this one. And why a current carrying conductor state conductor experiences a force because of the magnetic field lines that it produces, and it is beyond the scope of the 10th class syllabus. But because we have studied this, and a straight carrying conductor, whenever placed in a direction perpendicular to the direction of the magnetic field, it experiences a force. And this is a current carrying straight conductor. Net charge on a current carrying straight sector is always zero, which is also true. So B is the correct option for this. For next question, that is question number 25, we have to observe the following diagram and answer the questions following it. So these are the light rays coming from somewhere from infinity, and the image is formed in front of the retina. So that means that the far point of the normal human eye, which is infinity, it has, so this was a far point of the my, and it has come nearer. So we can say that the far point of the eye, so the far point of the eye that has far point is now nearer than the infinity. So in this case, the far point is nearer than the infinity. The reason here is why we are able to get the image here, because in front of the retina, because the far point which are supposed to be here, which was at infinity, it's now nearer than the infinity. It has come here. So we can write here that how we can identify this, because the far point is nearer than the infinity. So here the far point is nearer than infinity. So that means the far away objects we are not able to see that. The far point is nearer than infinity. So we are not able to see far away objects. And if we are not able to see far away objects, so not able to see far away objects means that the defect of vision is myopia, which is nearsightedness. So means we can see the nearby objects clearly but cannot see the distant objects distinctly. So the defect of vision shown here is, this is, we can write the defect of vision so shown here is myopia, which is also called nearsightedness, which means we can see nearby objects but cannot see far of the objects distinctly. It's nearsightedness. It's not that we are totally not able to see the far away objects, but we cannot see them distinctly. We cannot distinguish between two objects clearly. So this is myopia, or we can say the nearsightedness. Okay. Now, the next question, we have to list two causes for this. So two causes for this can be maybe this eye lens, eyeball is too long. So that could be the reason, the elongation of eyeball. So that's why the image is forming in front of the retina. So the reason here is the can be the elongation of eyeball, or maybe the curvature of eye lens is excessive. This eye lens, this is the eye lens, its curvature is excessive, like this. So the second possible reason could be, in this case, this is first, this elongation of eyeball, and second could be the excessive curvature of eye lens. This could be the reason for the myopia, which brings the far point nearer than infinity, and thus the image is formed in front of the retina. So this is the excessive curvature of, we can say, the eye lens. This could be the reason. Okay, now name the type of lens used for the correction of this defect. So this defect can be corrected by using a concave lens. So we have to use a concave lens, which is also called the diverging lens. So if we use the concave lens here, this will diverge these rays of light from okay, let me draw it like this. This concave lens is going to divert the rays of light to, like this, divert the rays of light and bring them at the retina. So this is a concave lens. So type of lens used for the correction of this defect is a concave lens. Concave lens, or we also call it diverging lens. And let me show you how this is corrected. Let's say this is an eyeball. Again, let's say this is the eye lens. And now we have to, so the far point is now nearer than the infinity. So it was supposed to be the far point here, but it's now here. So that means from here we have to get the rays of light. So rays of light coming from here. Here it's a concave lens. It's going to divert the rays of the light. Okay, so the rays of the light coming from this. This is the far point, which is nearer than the infinity. So far point is here now. So all the rays of light coming from here, which were meeting in front of the retina, it will divert these rays of light, will bring them out. Okay, let me draw this here. Let this be the ray of light. Okay, now it will divert the rays of light like this and will focus them the retina. So the image is formed exactly on the retina. So the far point is nearer than the infinity here, and from here the rays of light will be diverged and will be brought back to the focus at the retina. So this is how the diverging lens or the concave lens corrects the myopia, and we are able to see the distant objects distinctly. Okay, next question is the color of the sky, clear sky from the earth appears blue, but from the space it appears black. Why? So give the reason for the blue, and for the persons at the higher altitudes it's black. Let's give the reason for that. And the reason for that, the sky to be blue when we see it from the earth's surface, is that the size of particles in the atmosphere is smaller. So very, we can say the very fine particles or very minute particles present in the sky, they scatter light of shorter wavelengths. They scatter light of shorter wavelength, that is blue, because their size matches with the order of the wavelength of the blue light, that is the blue color or blue light, more than light of longer wavelength, that is red. So that's why the sky appears blue. You can say that is red color. So sky appears blue. And this is because of the scattering of the light by the very fine particles present in the atmosphere. So sky appears blue. But when we see this from high altitudes, and the question is why the Earth appears space it appears black. So when seen from space, because we are at high altitudes, we are out of the atmosphere of the Earth. So when seen from space, there is no atmosphere, and hence there is no scattering of light. There is no atmosphere in between, and hence there is no scattering of light. So if there is no scattering of light, means no colors are scattered, and hence it appears black. There is no scattering of light, and hence from space it appears black. So in this question, you have to answer why it's blue when seen from the surface of the Earth, or when seen within the atmosphere of the Earth, and why it's black when seen from the space because of the altitude and the absence of the atmosphere. So this is question number 25. Let's move on to the next question. Okay, for next question, which is question number 30. We have to define the following terms in context of a diverging mirror, and the diverging mirror is concave mirror. We have to define what is the principal focus, and we know that principal focus is a point on the principal axis where all parallel rays of light after reflection from the mirror they meet. Okay, let's say this is a concave mirror. This is the non-reflecting surface, means the light is not coming, and the reflecting surface is curved inwards. This is, let's say, the pole. This is the center of curvature, and this is the principal focus. The line passing through the center of curvature and the pole is the principal axis. So this is the principal axis. Okay, now all the rays of light that are coming parallel. So all the rays of light coming parallel to the principal axis. So after reflection from the concave mirror will go through a point, and that point is on the principal axis, which is called the principal focus. So this is the direction of the parallel rays of light, and this is how they will go. This is their path after reflection. So principal focus, which has symbol capital letter F. So we can say that it, in context of concave mirror, so it is a point on principal axis where all where parallel rays of light after reflection from the mirror meet, and it is denoted by F, by capital letter F. So this is the principal focus. Now the next is the focal length. So focal length is the distance. This is the distance between the principal focus and the pole, and it's denoted by F. So we have to write what is focal length. So focal length has the symbol small f. So this is small f, and it is the distance between the principal focus and the pole of the mirror. of the mirror, and it is denoted by small letter f. So this is the focal length, the principal focus and the focal length. So this was for part A. Now we have to draw a labeled ray diagram to illustrate your answer. This is the labeled ray diagram to illustrate your answer. And let's move on to the OR part, which is, so this was part A. Let's move on to the OR part B. So you have to do attempt any one of these. And okay, for next one, it's an object of height 10 centimeter. Object height is denoted by h, which is 10 centimeter, and is placed 27 centimeter away from the optical center of the converging lens's convex mirror. So this is convex mirror, converging lens, which converges the rays of light. So object is placed at a distance of 25 centimeter, and using the sign convention, it's negative. Okay, now it has focal length. So focal length for the converging lens, convex lens, is always positive. So this is 15 centimeter because it's behind the mirror. Now, sorry, behind the lens. Uh, it's always positive for the convex lens. Or is calculate the image distance. So we have to calculate the image distance, that is V, and height of the image, that is h dash. Now let's use the lens formula. So we are going to use the lens formula to find the image distance, and lens formula says that it's 1 upon v minus 1 upon u is equal to 1 by f. So we have to find v minus 1 upon u is negative 25, f is 15. So this becomes positive 1 upon v plus 25 is equal to 1 by 15, and 1 by v is 1 by 15 minus 1 by 25. So LCM of 25 and 15 is 75. Sorry, 60. It's 25. So LCM of 15 and 25 is 75. Sorry. So this is 75, and it's 5 minus 3, which is 2 by 75. So that means V is equal to 75 by 2, that is equal to 37.5 centimeters. So it's uh, the image is formed behind the lens and at a distance of 35.5 centimeter from the lens on the other side of the lens. Okay, so we have got the image distance. Now we have to find the image at height, and we know that the magnification is given by h dash upon h is equal to v by u. So we are going to consider only this combination. Now we have to find h dash h is 10. So this is 10 v. We are going to take the fraction part, 75 by 2, and u. So u is here, u is negative 25. So this is negative 25. So this is now equal to 75 by 2. I can write it as negative 1 by 25. 25 3s are is 75, and 2 5s are is 10. So h dash is equal to negative 15 centimeter. And negative means that the image is inverted and it's 15 centimeter in size. So this is h dash. Okay, let's move on to the next question. Okay, for question number 31, the power of a lens is 4D plus 4D. That means it's a convex lens. So we know that power of the lens is given by 1 upon focal length, which should be in meter. Now the power is 4 diopter. So this is 1 by focal length in meter. So that means the focal length in meter is equal to 1 by 4, which is equal to 0.25 meter. And in centimeter, this should be 25 centimeters. So this is the focal length of this lens. Now an object is placed at a distance of 50 centimeter. So u is equal to negative 50 centimeter, and state the nature and magnification of the focal length formed by the lens. So this u is negative 50, so that means it's double the focal length. That means it's placed at the center of curvature, and we have to also draw a ray diagram. So state the nature and magnification of the image formed by the lens. So Let's write the nature. So the nature is real and inverted. That's the nature, and we will show it using the ray diagram as well. And magnification. So because it's inverted, so we will use a negative sign, and it's equal to the size of the object because the object is placed at the center of curvature. So this is placed at twice the focal length, which is center of curvature, and we know that when the object is placed at center of curvature, image and the object size are equal, and when the image and the object size are equal, magnification is 1. So magnification is -1, nature is real and inverted, and let's just justify this answer. You can write this after you are done with the ray diagram. So I'm going to draw the ray diagram here. So let this be a convex lens. Okay, and this be a principal axis, this be the optical center. Okay, this be the optical center O, this be the first principal focus, and its double will be the second principal focus. So this focal length is 25 centimeter and U is at 50 centimeter. That means this is 50 centimeter, this is 25 centimeter, and this is 25. So its double is 2f, which is 50 centimeter. That's where the object is placed. So let this be the object placed here. Okay, and its arrow is pointing upwards. AB is the object. Now the ray of light that goes parallel will go through the first principal focus, second principal focus. Let this be F2 on the other side. Okay, this is okay. Now the ray of light that passes the optical center will meet this here, and this is where the image is formed. So this is where the image is formed. It's inverted. Okay, this is where the image is formed, and we are going to give the downward arrow for the inverted image and denote it by A dash B dash, and this is 2f2. So it's also formed at, this is the image distance, it's also formed at 50 centimeter is plus, and the object was at 50 centimeter. It's negative sign conventions. To the left it's negative, and to the right the distance is positive from the optical center. Okay, and let's give the direction for these rays, else half marks will be deducted for these. Okay, so this is the ray diagram, and now it's obvious that the nature of the image is it's real because the image is formed by the actual intersection of the rays, and it's inverted. So image is real and inverted, and the magnification here it's equal to the size of the object. So that let's give 1, and it's inverted, we will put the negative sign. So that's why the magnification is -1. Okay, so we have drawn the ray diagram to justify this answer. Let's move on to the next one. Okay, for question number 32, and this question has two parts, A and B. So why is an alternating current considered to be advantageous over direct current? So alternating current is the one, as a name suggests, alternating. It keeps on changing its direction uh, with the passage of time, or we can say during the fixed intervals. And direct current is the one which does not change its direction. The direction remains, it's a unidirectional current. So, so alternating current is advantageous for the long distance transmission of electric power. Why? Because the alternating current are, so that means the current has to be changed into the alternating current so that it can be transmitted over long distances. And because by changing the current, the alternating current, it can be we can reduce the loss of electric energy in the form of heat and in the form of sound energy. So we can say that alternating current can be transmitted over long distances without much loss of electric energy. So we can say that why alternating current is used. So alternating current is, so that means the electrical supply that comes to our home is the alternating current. So if we use the alternating current over long distances, it's economical. It reduces loss of electrical energy in the form of heat. So that's why it's considered the alternating current is considered to be transmitted over long distances. It reduces loss of electrical energy, you can say, in the form of heat. Because we know that whenever current travels over wire, in the wire, heat energy is produced because of the heating effect of electric current, but because we have to reduce that, so alternating current is the best option to transmit it over long distance. It reduces loss of electric energy in the form of heat. Okay, now this was the first one. For the second one, how is the type of current used in household supply different from the one given by the battery of dry cells? So household supply is AC and battery of dry cell is DC. So we can say that here household supply is alternating current. So that's the difference. It's the alternating current and a battery of dry cell, it's the direct current. That's the difference. Which is called DC. And DC is a current which is unidirectional, direction does not change, and in alternating current, direction changes. So this is, if you want to draw the graph for the alternating current, this is how it goes. And for the direct currents, it's unidirectional with the passage of time. It does not change its direction, it's constant. So this is DC and this is AC current. Okay. Now, how does an electric fuse prevent the electric circuit and appliances from the possible damage due to short circuiting or overloading? So, electric fuse is a safety device and it has a low melting point wire. So, when there is excessive current due to short circuiting or overloading, the wire gets heated and it melts, thus breaking the circuit. So, we can say that it, for the fuse, it melts and breaks down the circuits. When there is current of higher value than its rating. So if fuse is of 5 ampere and if current exceeds the rating of it, that is above 5 ampere, the fuse wire melts and breaks down the circuit. So it melts and breaks the circuit when a current of excessive value or higher value than its rating, because we have the ratings for the fuse going to it. That's how the fuse works. So it melts, breaks the circuit, and has no excessive current flows then. Okay, for next question, B, for the current carrying solenoid as shown in the figure, we have to draw magnetic field lines and give reason to explain that out of the 3 points A, B, and C, at which point the field strength is maximum and at which point it's minimum. Okay, so let me, this is the OR part, and we know that the solenoid is a closely wound insulated copper wire in the form of a cylinder. So this gives us the shape of the cylinder closely wound insulated copper wire with a number of turns. So this is a solenoid, and if the current is given to it, this is now a current carrying solenoid. Now when the current is passing through it, magnetic field lines inside the solenoid are parallel set of arrows, and they emerge from one end, which is called the north, which becomes the north pole, and merge at the other end, which becomes the south pole. So this is how the magnetic field lines goes. So parallel in the middle and form closed loops. So they emerge at one pole and merge at the other end. So where they emerge, so at this point, the magnetic field lines are coming out. So the magnetic field lines are coming out from here. So this is emerging point, which is called dot, and this is the merging point. The magnetic field lines, they merge here. They goes into the solenoid. So this is where it merge and it becomes south pole. So it behaves like a bar magnet. Now it's given that we have 3 points. One is in the middle. So we have 3 points. One is in the middle, which is point A. So let's say this is point A and the other one is outside here. Let's say this is point B and the other one is at the pole, which is point C. So where is the magnetic field lines? Sorry, the strength of the magnetic field line, we have to compare it at A, B, and C. So maximum strength, what is given in the question is at give reason to explain that out of 3 points A, B, and C, at which point the field strength is maximum, at which point it is minimum. So maximum and minimum, we have to identify these points where it's maximum and where it's minimum, and we have to give the reason. So maximum is at point A. So at point A, because the magnetic field lines are crowded. So point A here is this point. So it's maximum at point A because here the field lines are crowded. So we can say, and minimum is at point B because the magnetic field lines are, because if we draw more magnetic field lines there, here the magnetic field lines are, they have distance between them. They are away from each other. So this is the minimum and this is the maximum. The A point is the maximum because here the magnetic field lines are crowded. So maximum is at point A and reason because the magnetic field lines are crowded and the degree of closeness gives the strength of the magnetic field because magnetic field lines are crowded. Okay, now it's maximum at point A and minimum at point B because maximum at point A and minimum at point B because magnetic field lines, they are away from each other. They have some distance between them. So magnetic field lines, we can say they are far apart. Because if we draw some more magnetic field lines here, so if we draw a magnetic field line at this point, so these magnetic field lines are, sorry, these magnetic field lines will have some distance, so they are far away from each other. Here at point B we will have one more magnetic field line which will be far away from each other. So here the magnetic field strength is minimum, it's maximum here because the field lines are will be crowded here, and C is a point just away from the pole. So this is away from the pole. So this there will be some magnetic field strength here, but the maximum would be here because the magnetic field lines are more crowded here. And this is the direction of the current given to the solenoid because these are the turns of the solenoid. Okay, so maximum is at point A and minimum is at point B. Now next is at which point it is maximum and minimum. Okay, so we are done with part B. Let's move on to the next question. So for question number 36, it's asked how is electric current related to the potential difference across the terminals of a conductor, and this is what exactly is the Ohm's law. We have to draw a labeled circuit diagram to verify this relationship. So for first one, We can say that according to Ohm's law. So potential difference across the ends of a conductor or a metallic wire. So this is the potential difference across ends of a metallic wire is directly proportional to the current flowing through it. And the condition is that provided the temperature remains constant. Okay, this is the condition that the temperature remains constant. Okay. Okay, now we have to draw a label circuit diagram to verify this relationship. And let's draw the label circuit diagram. Let's say this is let this be the battery, and to the battery let there be a key, close key. This is a close key, and let there be an ammeter connected. So positive terminal of the ammeter is connected to the positive terminal of the battery. So let this be the ammeter. Let this be the variable resistance. This be the variable resistance rheostat, and it's connected. Let this be a device across. This be the resistance or the load resistance or the device across with which we will get the output. So let this be the potential difference. Okay. And the current flows in this direction from positive to negative. So more is the potential difference, more is the current. So V is directly proportional to I, or we can say that I is directly proportional to V. More is the potential difference, more is the current produced, or the current flows. Okay, now, next question is, why should an ammeter have low resistance? Now, this is the ammeter which is connected in series, which gives us the reading of the current. Now, that means that all current should flow through this ammeter so that it gives us the exact reading, and this will happen only when it has low resistance. So this should not obstruct the flow of the current. So that's why ammeter should have low resistance. And we can write here, since ammeter is connected in series, so an ideal ammeter should have zero resistance, we can say. Or let's write it here. For this, it's since this ammeter is connected in series, and it should not increase. So we know that whenever a device is connected in series, it increases the resistance of the circuit. So it is connected in series, but it should not increase the resistance. of the circuit. So we cannot take it out of the series. It should not increase, but instead we can have it, uh, we can make it so that it has a low resistance. So it should not increase the resistance of the circuit. And because it's giving us the reading, so that means it should allow maximum current to flow through the circuit. In the circuit, so ideally it should have low resistance or zero resistance. Okay, this is the reason. Okay, so now we have two VI graphs, and one is graph A and there is graph B. So A is for a series, and the parallel combination of two resistors. We have to give reason why it's which graph shows series or parallel combination. So it's not given which one is parallel or which one is series. Now we know that more is the slope, more slope. This is the I versus V graph, sorry. So for V versus I graph, more is the slope, more is the resistance. More slope means more resistance. But this graph is not V versus I. This is I versus V. So I versus V means this is I versus V. Now this graph. So here now it's more slope means more resistance for V versus I graph. So I versus V means that less slope means this is less slope means more resistance. Okay, so that means this is the slope, the angle which so this slope has less resistance, A slope has less resistance. This is less slope means greater resistance. And greater resistance means that A is in series, because in series the resistance increases. And the more slope means this is the more slope means less resistance. Less resistance means they are connected in parallel. Okay, so let's write down the answer now. What is the answer? So series combination is a graph. So we can say that for series combination, it's graph. Less slope and more resistance for I versus V graph. I versus V graph. Okay, the parallel combination is B. It's graph B because it has more slope means less resistance, and that is for I versus V graph. कितनी चैप्टर हो गए बेटा? Okay, let's move on to the next question. Okay, for question number 39, it's given that the ability of a medium to refract light is expressed in terms of its optical density. Now, the optical density is not exactly as the mass density. These are two different things. And for two media, the one with the large refractive index is optically denser medium than the other. So that means if we have two media and the one with the larger refractive index will be optically denser and one with the lesser refractive index will be optically rarer. So the other medium with a low refractive index is optically rare. It's given. Also, the speed of light through a given medium is inversely proportional to its optical density. That means more is the optical density, less is the speed of light in that medium. Now, determine the speed of light in diamond if the refractive index of diamond with respect to vacuum is 2.42. So let's answer the first part. This is okay. First one. Now, the refractive index of diamond. Let's say the refractive index of diamond is ND. D is for diamond, N is for the refractive index, and it's 2.42 with respect to the vacuum. That means it's the absolute refractive index. And refractive index of a medium is given by the speed of light divided by the speed of light in that medium. Okay, so here the medium is diamond, so refractive index of diamond is equal to C by speed of light in diamond. This is the diamond. Here medium is the diamond and refractive index of diamond is 2.42 speed of light. We all know speed of light is 3 into 10 raised power 8 meter per second. So this is equal to 3 to 10 raised power 8 divided by speed of light in diamond. And if we cross multiply this, now speed of light in diamond is equal to 3 into 10 raised power 8 divided by 2.42. So this is now, if we remove the point, this is 300 divided by 242 into 10 raised power 8 meter per second. So this is 100, this is 1 to 1. Okay, so if we divide 100 by 1 to 1, so 100 divided by 1 to 1 will give me this 0.826. So this is 0.826 into 10 raised power 8 meter per second. And so this is 3 upon 2.42. That's 1 to 1. Okay, actually this is, I have calculated it. So this is 3 into 10 raised power 8 upon 2.42. Now if I remove this point, this is equal to 300 upon 242 into 10 raised power 8. And if I have to cancel this with 2, this is 1 to 1. This should be 150. Okay, now we have to divide 150 by 1 to 1. So if I divide 150, so divide 150 by 1 to 1, which gives me 1.23. So this is now equal to 1.23 into 10 raised power 8 meter per second. This is the speed of light in diamond. 1.23 to 10 raised power 8. This is 10 raised power 8 meter per second. Okay, now the next part says the refractive indices of glass, water, and carbon disulfide are 1.5, 1.30, and 1.62 respectively. If ray of light is incident in these media at the same angle, then write the increasing order of the angle of refraction in this media. So we have three media: glass, water, and carbon disulfide. So let these be three media. So one is glass, and the second one is water. Let these be the media: glass, water, and the third one is the carbon disulfide. Okay, let these be the slabs of the first one is glass, and it has refractive index of glass is noted by Ng. So glass has refractive index 1.5. This is 1.5. Next one is water, and water has a refractive index of 1.33. Next is carbon disulfide. So this is carbon disulfide, and it has, let's say it's a carbon disulfide, I'm going to denote it with C and D, so it has 1.62. So its refractive index is 1.62. Okay. Now let the ray of light. So in this case, more is the refractive index, less is the speed of light in that medium, and the greater refractive index is here 1.62 than this. So that means the carbon disulfide, it has greater refractive index than glass, and the least is in the water. So that means the least will be the speed of light here. So speed of light in carbon disulfide will be least, speed of light in glass will be less than this, and the the greater will be the speed of light in water. Okay, now so refractive index here is it's 1.62, it's 1.5, and it's 1.33. So which, because the refractive index is inversely proportional to the speed of light in that medium, so this is how exactly it looks. Now let's incident a speed of incident a ray on all ray of light on all these media. Let this be the normal, and light is incident at the same angle. So light is incident at the same angle theta. So light is incident at the same angle theta. So this is, let's say, same angle. The angle of incidence is same. This is the incident and this is the normal. This is the normal. Normal means perpendicular to that uh, refracting surface. So here, in this case, refractive index is greater, so that means the ray of light will bend more towards the normal. So let this be the refracting angle. So this refractive angle, so in this case, the refractive ray, this incident ray will bend towards the normal but will be less than this one. So this will bend towards the normal but will be less than the, will bend less. So that means this angle of refraction is more than this one, this one. So let this be the angle of refraction. This is the angle of refraction R. So this is the angle of refraction. So this is greater than this. Now here the refractive index is less, so that means the speed of the ray will bend least in this case. So here the angle of refraction will be, this will bend least. So that means the angle of refraction, this, now we have to write what is asked in the question. The question is to write the increasing order of the angle of refraction. So increasing order means that we have to write the least one first. So least one is here. So that means the angle of refraction of carbon disulfide is the least because it will bend more towards the normal. So this is less than the angle of refraction in glass, and then the angle of refraction in water. Yeah. This is how the angle of refraction looks like. So it will bend more than the angle of refraction is less, least. It will bend less than this. So this, its angle of refraction is greater than this one, and it will bend least towards the normal. So here the angle of refraction is greater. So this is the increasing order of the angle of refraction. Now the fourth one, the speed of light in glass is this, and speed of light in water. So speed of light in glass, glass is the medium, and speed of light in water is given. So more is the speed of light, less is the refractive index. So 2 into 10 raised power 8 is the speed of light in glass. So 2 into 10 raised power 8 meter per second is the speed of light in glass. So this is the speed of light in glass, and speed of light in water is 2.25. So 2.25 into 10 raised power 8. So this is 2.25 into 10 raised power 8 meter per second. So here we can see that speed of light in water is more than the speed of light in glass, and more is the speed of light in water. So that means the refractive index So here the speed of light is less, so that means the speed of light in glass, so the refractive index of glass is more than the reflective index of water. So in this case, our option should be which one of two is optically denser and why. So we can write here that the refractive index of glass is more than the refractive index of water. So how do you write it? The speed of light in water is more than the speed of light in glass. We can write the speed, this is speed of light in water is glass. Okay, that means that is refractive index of glass is more. So less is the speed of light in medium, more is the refractive index. So that means the refractive index of glass is more than the refractive index of water. So that's the reason. Okay. Now, for the next question, so which of two is optically denser? We can say that glass is optically denser. More is the refractive index, more optically denser is the medium. More is the refractive index, more optically denser is the medium. Therefore, glass is more optically denser than water. Okay. Okay, now for the next one, it's given that a ray of light is incident normally at the water glass interface when it enters a thick glass container filled with water. What will happen to the path of the ray of light after entering the glass? We have to give reasons. So ray of light is incident normally means 90-degree at the water glass interface. So there is a water glass interface means the light is entering from water into the glass. So let this be the water and this be the glass. Now let's say this is the water and this is the glass. Now ray of light is entering normally means at 90-degree. So this is how the ray of light is entering. Now this is the incident ray from water, that is, and this is also the normal. So that means angle of incidence. So angle of incidence is equal to 0 because it's the angle between the incident ray and the normal. So this ray is the incident as well as the normal. So angle of incidence is 0. So that means the angle of refraction will also be 0. So that means the light ray will enter undeviated. So light will enter from water to glass without bending. We can say that light will enter from water to glass without bending, that is undeviated, or we can say that it will go straight. And reason is because angle of incidence is equal to 0. Angle of incidence is equal to 0 because the incident ray is also the normal, and angle of incidence is the angle between the incidence and the normal. So both are same. So that means angle of incidence is equal to 0, which gives us angle of reflection is equal to 0. So it will go without bending. And this was the answer for B part. So this was the B part. This was the A part, and this was the B part. I've explained this using diagram. And okay, for the next third one, the absolute refractive indices of water and glass are 4 by 3 and 3 by 2 respectively. So absolute refractive indices of water. So we know that absolute refractive index of a medium is given by C, where C is the speed of light upon Vm, where V is the velocity, Vm is the velocity of light in this medium. First medium is water. So refractive index of water will be C by Vw. And the refractive index of glass will be written by Ng, medium is glass, C by Vg. Now refractive index of water, this water is given which is 4 by 3, so this is C upon Vw. And the refractive index of glass which is 3 by 2, so this is 3 by 2 is equal to C upon speed of light in glass. Let this be equation 1 and let this be equation 2. Also, speed of light in glass is given, so that means this is given. Speed of light in glass is given, which is 2 into 10 raised power 8 meter per second, and we have to find the speed of light in vacuum. So speed of light in vacuum means C. So let's use this one. So here its refractive index is 3 by 2 C, and V speed of light in glass is 2 into 10 raised power 8 meter per second. So if we cross multiply this, C is equal to 3 by 2 into 2 into 10 raised power 8 meter per second. So this gets cancelled. So speed of light in vacuum is 3 into 10 raised power 8 meter per second. So we can write here speed of light in vacuum, which is also the speed of light in air. So speed of light in vacuum, which we denote by C, is 3 into 10 raised power 8 meter per second. Okay, now let's use this to find the speed of light in water. So let's use this equation. 4 by 3 speed of light in vacuum is 3 into 10 raised power 8. We have to find the speed of light in water. So let's cross multiply this, which gives us speed of light in water is equal to 3 into 3 into 10 raised power 8 divided by 4 meter per second. So speed of light in water is equal to 9 by 4 into 10 raised power 8 meter per second. And 9 by 4 is 4 2s are 8.25 into 10 raised power 8 meter per second. This is the speed of light in water, which is 2.25 into 10 raised power 8 meter per second. Okay, with this, we are done with question number 39, and this finishes this set as well. To like, share, and subscribe. Thank you for watching.